Welcome, everybody. We're talking about transformations. Okay, it's been quite the day for those of you that are in class, but we're grinding today, and we're talking about transformations. And as you can see, I've got a piece of paper turned sideways with a card drawn on it. Transformations is our title at the top, and this is probably the strangest start to a math lesson you've seen. Even though we do quite a few weird starts in my class, but what the heck am I talking about here? Why do we have a car drawn on our paper? The reason the way I like to teach about transformations of graphs is using a car, okay? And here's the reason why, okay? Let's go ahead and go to Desmos. And what I would recommend is that if you're following along, try to do the same, okay? I would recommend you go to Desmos, type in what I'm going to type in here. Let's whip up a couple different parent functions in our graph here. So I'm going to start with y equals x. That's our linear one. I'm going to have my y equals x squared. I'm going to go and I'm going to have y equals the absolute value of x. I'm going to get y equals, what's the other one? The square root of x. Maybe y equals x cubed. That's fine. I don't think I need all of them. Do me a favor, type those in for me. I'll give you guys just a second as you follow along. And so as you've typed this in, as you've typed these 5 in, what I'm looking at here is all 5 parent functions. And luckily Desmos has got 5 different colors, so this looks beautiful. I've got a black graph, which is a V. That's an absolute value. I've got a red graph. Now, your colors are probably different. But my red graph is a square root. I've got my purple graph is a quadratic, is a parabola, is a U shape. I've got my blue graph is my little swerving little cubic. And then I've got my green line, which is a linear line. And something that they all have in common, every single graph, is this point right here. 0, 0. Okay. Now they also happen to all have this point in common, but that's more of a coincidence for now. Don't think of this as important. And what's really important about 0, 0 is not only do they all have it in common, but it is also like the middle of the graph for all of them. Okay. So for linear, it doesn't make as much sense because it's just a line. But for this quadratic, you can see 0, 0 is the middle of the graph here, right? If I go to my absolute value, it's the middle of my absolute value. If I go to my square root graph, a little bit weird because it only has a right side. It does not have a left side. But you can see how 0, 0 is kind of where it starts. So 0, 0 is still kind of like the middle, or maybe it's like the most important place. And then if I check out my x cubed, it's right in the middle as well. Okay, now we're going to go ahead and call this another vocab term. Okay, so we're going to go over here and we're going to call this the vertex. Now the vertex would be like that middle point of the graph. Okay, so that vertex is the middle of the V, the middle of the U, the middle of the swerve. And so this is not necessarily a super textbook definition, but this vertex is the middle of the graph. Right? If you were going to look this up in a textbook, it wouldn't say this. It would be a lot more complicated, but I think this is a good enough definition for us today. Okay? The vertex is that middle. And we just looked at a whole bunch of graphs. And these transformations, let's go ahead and put this vertex into a box here. Maybe we'll title it vocab on top. Right? These transformations, these are all in vertex form. So that's something we definitely want to write here. All of these are going to be in vertex form. So, what does that mean? Well, what that means is that all of these parent functions, they're all going to work very, very similarly, okay? If I do something to one and I do the same thing to the other one, I expect them to react in the same way. And so the way I'm going to demonstrate that to you is let's go ahead and let's turn off the linear and let's turn off the cubic, okay? So let's work with just three of them because I know it's crazy when you have more than this. When I'm working with just these three, if I go up to my quadratic and I put plus 2 at the end, let's talk about that, okay? How has my quadratic been changed by putting that plus 2 on the end of it? What do you think? What would a kindergartner say? Yeah, it went up, right? When I put the plus 2 there, it went up, and you can see it's up at 2 now, okay? Now, if I do the same thing to the absolute value, same thing should happen, right? It should go up 2. If I do the same thing here to the square root, it should go up 2. So a really, really, really important understanding when it comes to these parent functions and these vertex forms is that every single one is going to behave the same. Now, since we're talking about this number out behind, let's do a little trick here, okay? I want you to do this. Delete the 2 and replace the 2 with the letter K, okay? So put a plus K, put a plus K, put a plus K, and put a plus K on all three of those so that your graph kind of looks like this. Maybe I'll drag this one down so it's at the bottom. So now that I have a plus K, my graphs have disappeared. And my graphs have disappeared because too many variables try defining K. Desmos has no idea what K means, okay? Now, if we click this button, add the slider for K, we click that. This slider right now is a way for us to change what K is. So right now, our K is 1. I can slide this, and I can make K 2, and I can make K 3. And as you can see, all of my graphs are moving in the exact same way. If I move K down, the graphs go down, right? Simple as that. And I can even press this play button, and it will automate. Let me zoom out a bit. And it will automate going up and down, etc. So what we've just kind of recognized, and I will go ahead and bring it back to 0, is that this number K that is put on the outside of our shape is moving us up and down. I'm sure you guys would all agree with that. And so what we're going to do here is we're going to start to fill in our car a little bit, okay? We're going to go ahead and out front of the car, I want to put y equals, I want to leave a little bit of a gap here. So make sure you do that. Inside the car, I want you to put an X, and I want you to put it in the front, like in the front seat of the car. So don't put it right in the middle. If you put it right in the middle, that's okay. But I'd like it to be in the front seat for the most part. Excuse me. And then in the back of the car, I want you to put plus K. Okay. Now we just saw what that K did. Okay. So now let's go ahead and let's do one of these. If you've got different colors, this is a great time to do it. Maybe you don't want to circle the K, you just want to do an arrow. But whatever you want to do. What does the K do to our function? Okay. The K, very simply, this is what a kindergarten would say, moves the graph up and down. Okay, and that's the same for all of them, right? That's the same for absolute value. That's the same for square root. That's the same for quadratics. If you see a plus 5 that's at the end, then you know that the graph has been moved up 5. Every single one of them. They've all gone up 5. So Hopefully that's relatively easy. Now let's go back to our Desmos. And now let's look at what happens with another letter, okay? This time, I want to put another letter H on our function. Okay, now if I put the H out back with the K, now it's plus H plus K. They're just forming one mega number, and it's all the same thing, right? But if I put the H inside of the absolute value, if I put the H inside of the square root, and this one's a little tricky. If I put the H inside of the squared, now if I'm going to do this, I'm going to need parentheses. Make sure that I get the H on the inside with the X. So really important now, notice that the H is inside of the shape with these numbers or with these graphs, and that the H is with the X inside the car. If you think about this as a car, the H is inside the car with the X. The H is inside the car with the X. So let's go back over here. Let's go ahead and fill this in. We're going to go ahead and put an H on the inside of our car. It's not a very handsome H. A little bit better there. H can be in the back seat. What does this H do? Okay, let's add a slider for H. We know that the K was moving it up and down, right? We put the K back at 0, so the K wouldn't bother us. What does the H do? Side to side, right? It's not rocket science. The H is moving us side to side. There's something else going on here, though. What else is going on? Girls in class, you guys seem to be killing it. Anything weird about this? So look, as my slider is going left, my graph is going right. As my slider is going right, my graph is going left, okay? When my slider gets to -10, my graphs are at +10. So H is a little tricky, okay, because it moves you left and right. That's not a surprise, but +5 slider means -5 graph. If I go to +7 graph, I'm at -7 slider. Okay, so right here, we need to go ahead and fill this in as well. That our H, and again, this is what a kindergartner would say, doesn't move the graph up and down. Our H moves the graph left or right. But very specific here. This is one of the most important things on the whole piece of paper that we're going to write today. Okay, this is moving it in the opposite direction. And we know that because if I get rid of my H right here on this purple graph, let's turn off the other graphs. If I put my H as a +3, my graph goes to -3. If I put my graph at a -1, my graph goes to a +1. If I put it at -10, it goes to +10. Okay, so that number on the inside is your left and right number, but it's working opposite what you would think. Okay? Now, the last two things that I want to talk about today is I want to talk about numbers that go in front of the car with multiplication. Okay? So we're going to put a negative A. We're going to put a negative and an A out front. Hopefully, I have enough room for that. I might even go back and make mine red. Negative A. Because I don't want it to blend in with the equal sign. So what happens with the equal sign or with the A? So let's go to Desmos and let's find out. Let me put my H back in here. Let me turn these on. Let me move my slider. Okay. Let's put an A in front of our car for all of these. Let's add the slider for A. Let's move our H back to 0. Perfect. So we had all these right in the middle. Our A is going to, as we increase the A, our A is going to be stretching our graphs up, okay? As we increase A, it's stretching it up and stretching it up and stretching it up and stretching it up. And then as we lower A, it is going to be compressing it down, right? Like weighing it down, pulling it down, compressing it down. Now, it's going to keep pressing it down, keep weighing it down, and then right when we get over into the negative numbers, boop, it's going to pop upside down, and our graphs are going to be upside down. So if we look at that automated, on the negative side, it's an upside down version of the graph. On the positive side, it's an upright version of the graph. And you can see how when that number is getting higher, it is stretching it. When that number is getting smaller, it's compressing it. Higher, it's stretching it. Smaller, it's compressing it. And so what I want you to do here is I want you to make sure you've got two different arrows. Okay, the A, I'm going to do an arrow for the A. And this A is going to do a stretch or compress. Now, truly, stretching or compressing, this is an Algebra 3. This is a trigonometry. This is a math analysis type question here. Okay, stretching or compressing, we do not see it a whole lot in Algebra 2, to be honest with you. It exists. You need to know it, but we don't see it very much. Okay, it's really the negative sign that you need to know what it does, right? And the negative sign is different from the A, right? The negative has nothing to do with stretching or compressing. The negative is going to flip your graph upside down. Now, let's talk about what we're looking at here. We've got vertex form parent functions that we're looking at here, okay? We've got, A, K, and H of all three of these parent functions, and they all work the same way, okay? The reason that I've drawn a car is because I don't want you to think that this only works for absolute value graphs, right? Because it doesn't only work for absolute value graphs. It also works for squared graphs. It also works for square root graphs, right? It works for all of these. And so I just like using a car because for me, it's just like, okay, who cares what shape is around this? I just need to know, is the H on the inside of the shape or is it a K on the outside? We know that any number added outside of the shape moves us up and down. Any number added inside of the shape moves us left or right, opposite of the sign that we think. And if we have a negative out front, it's going to flip us upside down. So we can keep that in mind, okay? Let's see. I'll shrink this down a bit. We could do a question where I ask you this, okay? If I have y equals negative absolute value of x plus 2, how is this function transformed? How is this function different from the regular old function, right? If I think about the parent, I know that the parent is y equals absolute value of x. I know that the parent looks like this, a V shape right in the middle. What is different about this graph here? Okay, now you're going to look at your car and you want to think about, here's a negative that's not over here. So what has that negative done to my shape? Flipped it upside down, okay? What about this 2? How has this 2 changed my graph? Let's move this up 2, right? This would be considered a K, and so this would be considered to move us up 2. And that's the only difference between these two graphs, the blue graph and the black graph. So I can now graph the blue graph. I don't need Desmos's help. I can start with a V, and I can move it up 2, right? Check. And then I need to flip it upside down. So I can flip it upside down. And there you go. That is what this graph should look like. It's the parent of the V upside down, up 2. And so it should look like this. We go to Desmos, and then we go to type it in, right? Let me get rid of all of these. Y equals negative absolute value of x plus 2. Perfect, right? An upside down V that's moved up 2. And so now what you have is a study guide for the different parent functions and a study guide for the transformations. If you see a number out back, it's going up or down. A number inside, it's going opposite, left or right. A number out front, stretch or compress. A negative out front, flip it upside down. That's everything you know how to graph. So this is a huge portion of graphing in Algebra 2. This is technically everything you need to know as far as how to actually graph stuff. So from now on, all we're going to be doing is reading graphs and not really doing the actual graphing ourselves. But that's it for today. I know it's been a long